Two six-sided dice are rolled. What is the probability that the sum of the numbers rolled is a multiple of 4 or is 5? First, you want to find the total number of possible outcomes. Because there are 6 possible outcomes to rolling the first die and 6 possible outcomes to rolling the second die, there are a total of 6 times 6 or 36 possible outcomes to rolling both dice. Let event A be the sum as a multiple of 4. Of the 36 total possible outcomes, the ways in which event A can occur are to roll a 1 and then a 3, to roll a 2 and then a 2, to roll a 2 and then a 6, to roll a 3 and then a 1, to roll a 3 and then a 5, to roll a 4 and then a 4, to roll a 5 and then a 3, to roll a 6 and then a 2, and to roll a 6 and then a 6. Let event B be the sum is 5. Out of the 36 total possible outcomes, the ways in which event B can occur are to roll a 1 and then a 4, to roll a 2 and then a 3, to roll a 3 and then a 2, and to roll a 4 and then a 1. Because A and B are disjoint, the probability of event A occurring or event B occurring equals the probability of event A occurring plus the probability of event B occurring. Because there are 9 possible ways in which event A can occur, the probability of event A occurring is 9 divided by 36. Because there are 4 possible ways the event B can occur, the probability of event B occurring is 4 divided by 36. 9 divided by 36 plus 4 divided by 36 equals 13 divided by 36, which is approximately 361 thousandths. So the probability is about 361 thousandths. A bag contains cards numbered 1 through 20. One card is randomly selected. What is the probability that the number on the card is a multiple of 3 or a multiple of 4? Because the cards are numbered 1 through 20, there are 20 possible outcomes. Let event A be the number as a multiple of 3. Of the 20 possible outcomes, the ways in which event A can occur are for the number to be 3, 6, 9, 12, 15, and 18. Let event B be the number as a multiple of 4. Out of the 20 possible outcomes, the ways that event B can occur are if the number is 4, 8, 12, 16, or 20. From the diagram, A has 6 outcomes and B has 5 outcomes. Of these, one outcome is common to A and B. So the probability of event A occurring or event B occurring equals the probability of event A occurring plus the probability of event B occurring minus the probability of events A and B occurring. The probability of event A occurring is 6/20. The probability of event B occurring is 5/20, and the probability of events A and B occurring is 1/20. 6/20 plus 5/20 minus 1/20 simplifies to 10/20ths or 5/10ths. So the probability is 5/10ths. Out of 45 customers at a breakfast cafe, 42 customers bought either coffee or orange juice. There were 30 customers who bought orange juice and 40 customers who bought coffee. What is the probability that a randomly selected customer bought both coffee and orange juice? Let event A be the customer bought coffee, and event B be the customer bought orange juice. The probability of event A occurring or event B occurring equals the probability of event A occurring plus the probability of event B occurring minus the probability of events A and B occurring. From the given information, you know that the probability of event A occurring or event B occurring is 42 divided by 45. The probability of event A occurring is 40 divided by 45, and the probability of event B occurring is 30 divided by 45. The probability that a randomly selected customer bought both coffee and orange juice is the probability of events A and B occurring. So solve the equation for the probability of events A and B occurring. 40 divided by 45 plus 30 divided by 45 minus 42 divided by 45 simplifies to 28 divided by 45, or about 62 hundredths. So the probability is about 62 hundredths. A medical association estimates that 10 and 9/10% of the people in the United States have a thyroid disorder. Suppose a medical lab has developed a simple diagnostic test that is 96% accurate for people who have the disorder and 99% accurate for people who do not have it. The medical lab gives the test to a randomly selected person. What is the probability that the diagnosis is correct? Let event A be person has a thyroid disorder, and event B be correct diagnosis. Notice that the probability of B depends on the occurrence of A, so the events are dependent. Then the complements of events A and B are: event A bar is person does not have a thyroid disorder, and event B bar is incorrect diagnosis. A probability tree diagram where the probabilities are given along the branches can help you see the different ways to obtain a correct diagnosis. Notice that the probabilities for all branches from the same point sum to 1. To find the probability that the diagnosis is correct, follow the branches leading to event B. The probability of event B occurring equals the probability of events A and B occurring plus the probability of events A bar and B occurring. The probability of events A and B occurring equals the probability of event A occurring times the probability of event B occurring, given that event A has already occurred. And the probability of events A bar and B occurring equals the probability of event A bar occurring times the probability of event B occurring, given that event A bar has already occurred. The probability of event A occurring is 109 thousandths. The probability of event B occurring, given that event A has already occurred, is 96 hundredths. The probability of event A bar occurring is 891 thousandths, and the probability of event B occurring, given that event A bar has already occurred, is 99 hundredths. 109 thousandths times 96 hundredths plus 891 thousandths times 99 hundredths simplifies to approximately 987 thousandths. So the probability that the diagnosis is correct is about 987 thousandths or 98 7/10%.